All right, ladies and gentlemen, today we are going to have a look at how to compare and order rational and irrational numbers. And my goal is by the end of this lesson, you will all be able to compare and order rational and some commonly known irrational numbers. In order to do this, the first thing that we have to do is understand what rational and irrational numbers are. So, if we look at rational numbers, a rational number by definition is any number that can be written as a over b in which a and b are integers. So I want you to think about this. 1 and 25 hundredths. Is this a rational number? Can it be written as a over b in which a and b are integers? If you said yes, you are absolutely correct because we can actually write this number as 5 over 4, 5/4. And 5 is an integer as well as 4 because integers are all the positive and negative whole numbers. Now, let's take a look at another one. Can this number be written as a over b in which a and b are integers? Is it a rational number? Now, oftentimes I've heard it mentioned that if it's a repeating decimal, it's not a rational number, and some people, I think, have misconceptions and don't quite understand the definition or what an actual rational number is. Because this can be written like this. Negative 2 over 3. Is negative 2 an integer? Is 3 an integer? If you answered yes, then that means this is a rational number, and it is in fact a rational number. When comparing and ordering rational and irrational, we have to know a little bit about rational numbers and irrational numbers and how they can be written. Here are some irrational numbers. And here are two rational numbers. These numbers that I just allowed you to see are rational because the square root of 1, or radical 1, is equal to 1. And the square root of 4 is equal to 2. If we use some common, well-known radicals like square root of 1, square root of 4, then we can set up limits and figure out about what these values are equal to. So the square root of 2 and the square root of 3 are going to be somewhere between 1 and 2 when we're ordering them on a number line. Now, square root of 3 is actually going to be closer to 2, and square root of 2 is going to be closer to 1. So I might even set up a limit and say that this is 3/2, or you could also call it 1.5. Is 1.5 a rational number or an irrational number? That's right, it's rational because 3 and 2 are both integers. And now I can get a pretty reasonable estimate of about what the square root of 2 is equal to. Then I want you to go ahead and pull out a calculator and let's plug this value into your calculator and see what it equals. So 2 square root is equal to 1.41421, etc. And I'm just going to write that value up here. This is equal to 1.41 if I round to the nearest hundredth. And let's do the same thing for the square root of 3. So I pull out my calculator, I'm going to clear it, and hit 3 square root, 1.73 something. Okay, and I'm going to go ahead and exit out of that, and I'm going to write that up here, 1.73. So, whoops, I wrote 7573. So once we have this written, now we've already got we had a pretty close estimate. I was actually within 9/100ths of the square root of 2, and I was within 23/100ths of the square root of 3. And we just did that by coming up with some limits. Let's take a look at some more examples here. So in our practice problem we have, it says compare the following numbers. in which we have some irrational numbers and some rational numbers. We're going to learn how to do this by the end of this lesson. I want to take a closer look at the square root of 54. And I want you to think about what numbers or what radicals would be less than and greater than 54. And make sure they're radicals that you know the value of. And then we're going to write them as whole numbers. So what did you come up with? The square root of 49 and the square root of 64. This tells us, since the square root of 49 is 7 and the square root of 64 is 8, we know that the square root of 54 is going to be somewhere between 7 and 8. Now, to get a little bit closer estimate, what I like to do is look at the distance between just the whole number, 54 and 64. They're 10 units apart. And if I look at the distance between 49 and 54, it's 5 units apart. Now, that is actually a total distance of 15 units. If I rewrite this, and I'm thinking about those distances, how far they are apart, the 5 over 15 tells me how far from 7 to get to 54. And this simplifies to a fraction of 1/3. And that is equal to 0.3 repeating. So now, using this understanding, I'm going to make a close estimate. And it works better as the numbers get a little bit larger. And it will be even more accurate as they get larger. But my estimate is going to be 7.33. Now I'm going to pull out the calculator again and test this theory out. So 54 and the square root of 54 is 7.348. So I was actually within about, if we rounded to the nearest hundredth, 7.35, I'm within 2/100 of the exact value. Close that out. Now, what if we did the square root of 59? We're going to try this one now. And you notice when I put the square root of 59 in, it's still going to fall somewhere between 49 and 64. Square root of 49, square root of 64. And this time it's 10 units from the 49. So I'm going to write a little bit different fraction here, 10 over 15. And this simplifies to 2/3, which is equal to 0.6 repeating, so I get a value here of 7.66. And once again, if we pull out our calculator and double check this, the square root of 59 is 7.68. So again, I was within 2/100 of the exact answer. So I'm going to close this out. Now we're going to look at the square root of 75. What would you do if you had the square root of 75? And again, we would set up our limits. So we want to find a lower limit and an upper limit. And you guessed it, the square root of 64 and the square root of 81. Those are both perfect squares. And that's going to give us our upper and lower limit. 64 square root is 8, and the square root of 81 is 9. Now all we have to do is look at the distance between the different numbers. And it's 11 units to get to 75 from 64. And from 75 to 81 is 6 units. That's approximately 18 units. And the reason I use the 18 is because when we rewrite this as a fraction here, we're going to write 12 over 18. And I'm using a number that's compatible with 18. Since I have 11, I want something that I can simplify very easily into a common known decimal value. And 12/18 simplifies to 2/3, which is 0.6 repeating. Now, that tells me that it's 2/3 of the way between the square root of 64 and the square root of 81. And 2/3 of the way between 8 and 9 would give me a value of 8.66 repeating. So once again, if I check this with my calculator, all I have to do is put the square root of 75 in here, and you can see I actually was extremely close with that estimation, and the exact value you can see here. So using this, you can actually determine what the approximate value is of a radical or an irrational number. Now, how do we compare these numbers? Well, the first thing we need to do is convert them to the decimals like we've already done. We said this value was 7.66, this was 7.33, and this one was 8.66. The next, we want to convert these into decimals. These two are already done for me. And this one, 15 over 2, is 7 1/2, or 7.5. Once you have all of them written as decimals, then we can start comparing them and see which one is the least or the greatest. So I have them right here, and I'm just going to ungroup these and start putting them in order. So the first, I look at the ones place, or the place value that's farthest to the left, and I start maneuvering them. I want the 8s over here and the 7s over here, and 7.3 is going to be less than 7.6, and 7.5 is also going to be less than 7.6. So now, since I've got them in order, all I have to do is convert them back to their actual values. And we're going to do this right here, and we get our order from least to greatest. Well, I hope this helped you out with comparing and ordering rational and irrational numbers. See ya!